Welcome to Mega Technical Hub. Today we will study the most common defect, that is unbalance, and its types. When the machine is unbalanced, it shows different characteristics. So to diagnose and pinpoint the unbalanced defect, we need to understand thoroughly the different characteristics. That is how the phase varies at different measuring points and what is the dominating peak in the spectrum when unbalance occurs. That we will study in the later slides in detail. First, we would like to know what is unbalance. Unbalance is the condition where shaft geometric center line and mass center line do not coincide. What is shaft geometric center line? It is a line passes through the shaft and the bearings. And the mass center line is the point about which the mass is evenly distributed. When the equipment is properly balanced, there is no gap between the shaft geometric center line and the mass center line. They are coincide with each other. Single line, it represents both shaft geometric and mass center line. When the equipment is unbalanced condition, then there is a shift between the mass center line and the geometric center line. There is an offset in between these two. This red arrow, it shows the mass center line, and the blue arrow, it shows the shaft geometric center line. So they don't coincide with each other when the equipment is unbalanced. Because of this unbalanced force, this equipment tries to rotate about its CG, that is mass center line, but the equipment is holding by its foundation boards and bearings are there to support the shaft, and it don't allow the shaft to rotate its CG. So because of this effect, there is undue stresses are developed on the bearings because of this unbalance. So to occur the unbalance, there will be an uneven distribution of mass. Uneven distribution of mass means either there will be a material removal from the surface because of wear and tear, like this A and B, or there may be deposition, external deposition, that is dust, C and D, or there may be some broken parts in the component that also creates the unbalance. There are mainly three types of unbalance exist for any equipment. That is static unbalance, second one is couple unbalance, third one is dynamic unbalance. All these unbalance we'll study in the later slides in detail, and I explain for this center hung machine. Center hung machine means the impeller is supported either side by means of bearings. Here this is a DE bearing, this is ND bearing. They are either side of the impeller. What is force or static unbalance? Force unbalance, generally known as static unbalance. When it happens when the mass center line is displaced and it is parallel to the shaft center line, and this is the mass center line and displaced and is parallel to the shaft center line. There is an offset between these two and they are parallel to each other. When this static unbalance occurs in the machine, when there is a heavy spot or some unbalance lie on the single plane, either single mass very near to the CG of this here in this case, and the second case there may be two equal masses on either side on the same plane like A and B. In both the cases we can balance in the stopped condition. Just to rotate manually the impeller by hand because it is mounted on the bearings. Then during stoppage, this unbalanced mass, it comes to the rest position here at the 6 o'clock position. Then we need to balance this impeller by putting the balance weight at the opposite to that earlier heavy spot. In this way, we can balance the machine in case of static unbalance. If there is single mass is there, then you can put the single mass exactly opposite here or very near to the CG point here. In case of two separate masses on either side of the plane, in case of this figure, in this case you can put a single weight by the sum of these two weights A and B. For example, this is 1 kg, this is 1 kg. You can put the 2 kg very near to the CG of this point here, or also you can put opposite to this exact 180 degree of the earlier unbalanced forces. Then how to diagnose the static unbalance? By measuring having some phase analysis. You need to put the two accelerometers in horizontal and vertical directions, and the phase difference between the horizontal and vertical is 90 degree, or you can also write 90 degree plus or minus 30 degree. When you get this type of phase in between the horizontal to vertical, then you can diagnose as this is a static unbalance. Apart from this, again we can conclude this static unbalance by having different phase on the different measuring points. Here I am explaining by taking an example of this motor coupled with pump here, and have taken the phase at different positions, like one is NDE, 2 is DE point, like similarly 3 is DE drive end, 4 is NDE non drive end. In this case, by using this tachometer here, I measured the phase on different measuring points in X, Y, Z direction, means horizontal, vertical and axial directions. Because of this static or force unbalance, you will get different phase readings across horizontal, vertical, axial. If it is pure static unbalance, then you will get 1 into RPM in the radial directions. Radial means either horizontal or vertical in the spectrum. Mostly you get the 1 into dominating peak in the horizontal direction because of stiffness in the horizontal direction, less stiff in the horizontal directions compared to vertical direction. And the phase readings you will get like this. In case of pure static unbalance, if the horizontal phase at 1 means NDE, 2 means DE, the horizontal you are getting, suppose 1 and 2 is motor points, 30 degree, and at the 2 point is 25 degree. They are almost same in the horizontal direction. Similarly, in the vertical direction, here also phase are same, is 120 degree and 110 degree. This is the one of the case. Again, second is the horizontal phase difference and the vertical phase difference, they are approximately equal. In this case, 30 minus 25, 5 degree, 120 minus 110 degree, this is 10 degree. So both are approximately equal. So these are some of the characteristics. I will summarize in this slide here. First point is, in case of static or force unbalance, the maximum force is 1 into RPM, and it presents both in DE and NDE bearings. And with this pure force unbalance, ND horizontal phase is equal to D horizontal phase, 30 degree or 25 degree, both are similar here, close to each other. Likewise, ND vertical phase should approximately equal to D vertical phase. In this case, T vertical here 120 degree, 110 degree, we are nearer to each other. And force unbalance only requires single plane correction with the counterweight acting through the rotor CG. By using single plane balancing, you can do correction here. And the difference in horizontal D and D phase should approximately equal to phase difference in D and D vertical phase. Means horizontal 30 minus 25 degree, vertical 120 minus 110 degree, 110 degree. They are approximately close to each other. Next, consider couple unbalance. Couple unbalance is a condition where the mass center line intersects the shaft center line axis here at the center of geometry. In the earlier case, this mass center line and geometry center, they are parallel to each other, but in this case there is an interaction between the mass center line and the geometric center line. In this case, couple unbalance, there are two equal masses here, A and B. They lie in the opposite plane, 180 degree across. Then there is a couple unbalance, means the rotating equipment, it wobbles during the rotation. In this case, when you, in the stopped condition, when you rotate the impeller, then there is no static unbalance here, means it will not unbalance weight is at the opposite both the 180 degree, then it will not, heavy spot will not stop at the bottom in case of couple unbalance. Similarly, that couple unbalance, like the static unbalance, the phase difference between horizontal and vertical is 90 degree here, or 90 plus or minus 30 degree you can consider. And similarly, here also I am explaining by taking an example of motor with pump here. In case of motor, here there is one point is ND bearing, 2 is DE bearing. Similarly, pump here DE and DE. So here you are taking the phase by means of some tachometer arrangement here, and phase readings I noted down here because of this couple unbalance. Similarly, we will get here 1 into RPM peaks at the spectrum. Here vertical is amplitude, horizontal is spectrum. 1 into RPM dominating peak, that is also in the horizontal direction based on the stiffness in the horizontal plane. And these are the different angle phase measurements we obtained because of this couple unbalance. In case of couple unbalance, these two equal masses, they are opposite to each other, that is 180 degree out of the plane. Then we will get the phase difference here like this. This one is D and D, 2 is D. Across D and D and D, you get 180 degree phase difference. See here, 30 degree minus 210 degree, that is 180 degree. Similarly, in the vertical plane, 295 and 120, you are also getting similar to the nearer to the 180 degree. So in this case, couple unbalance, horizontal D and D and vertical D and D, the phase difference is around approximately 180 degree. And again, the horizontal phase difference and vertical phase difference, they are almost equal. In this case here it is 180 degree, and in this case 295 minus 180, sorry, this is 175 degree, means almost is nearer to the 180 degree. So in this case, couple unbalance, you are getting phase difference of horizontal phase difference, vertical phase difference of 180 degree. This is the diagram you can see here. This arrow mark is here and this arrow mark is here. This is 180 degree out of phase across DE and NDE. So as summarize, we can summarize these characteristics of couple unbalance as below. In case of pure unbalance, couple unbalance, the rotor is statically balanced but will not roll to the bottom when the rotor is placed on the knife edges. Couple unbalance generates high amplitude vibration is 1 into RPM on D and D bearings, and it may somewhat higher at one bearing than the other based on the stiffness. Horizontal phase difference between D and D bearings will approximately 180 degree. Similarly, in the vertical plane, the phase difference also same 180 degree. And again, 180 degree phase difference between D and D, it is 210 minus 30 degree here. And 170 degrees phase difference between 1 and 2 vertical, 295 minus 120, that is 170 degree. Both are very nearer. So these are some of the characteristics to diagnose the couple unbalance. Finally, we'll study about the dynamic unbalance. When dynamic unbalance condition exists, when there is mass center line is neither parallel or nor intersects the shaft center line axis, is a combination of both static unbalance and couple unbalance. It generally requires the correction at two planes. In this case here, this mass center line or geometric center line, they are either coincides or they are either parallel to each other. In dynamic unbalance also, we will get the 1 into RPM dominating peak in the spectrum. This is what amplitude, this is the frequency. 1 into RPM is the dominating peak, and it is also more in the horizontal direction based on the stiffness. Radial means horizontal and vertical, but horizontal is amplitude is very high compared to vertical. Again, I am explaining here by taking the example of this motor and pump coupled. One is similarly NDE, DE, NDE, here DE. Sorry, this is DE, this is NDE. Here also similar, you are getting the 90-degree phase shift between the horizontal to vertical. Again, some of the other phase differences here summarized in the table here. In case of horizontal, you can see here for DE and DE 90 minus 30, that is 60 degree. Again in the vertical direction 180 minus 20, again 60 degree. Yeah, means the horizontal DE and DE, there is a phase shift of, there is a phase difference of 90 degree plus or minus 30. You will get here. Similarly in the vertical also 90 degree plus or minus 30. And again phase difference in the horizontal plane and in the vertical plane, they are approximately equal. 90 minus 30 60 and 180 minus 120 60. Both are approximate equal. So as a summary, I am explaining here, dynamic unbalance generates high vibration 1 into RPM, but the amplitude of ND bearing may be somewhat different than the DE bearing based on the mass distribution on the impeller. Like force and couple unbalance, phase is steady and repeatable when dynamic unbalance dominates. Although horizontal phase difference between the outboard means ND, inboard means DE, could be anything from 0 to 180 degree. So the difference should still approximately equal to vertical phase difference. Means horizontal and vertical phase difference are almost same. Whether or not force couple imbalance dominates, the horizontal phase difference in bearing 1 and 2 should approximately equal to the vertical phase difference. So these are some of the characteristics of the dynamic unbalance. So till now I have explained about the center hung fan, but it is slightly different for the overhang fan, because in case of overhang fan, both the bearings here DE and NDE, this is NDE, this is DE, these are at one side, either side of the impeller. The impeller it is in overhang condition. It is called as overhang fan. In case of overhang fan, the spectrum is slightly different than the center hung fan. In case of overhang fan, there is a bending moment acts here because of this weight at one side. Because of bending moment, there is an axial thrust at these bearings. Because of axial thrust, axial vibration is higher. In case of overhang fan, that is 1 into RPM more in the axial, also more in the radial. So overhang rotors can generate large axial force of 1 into RPM, which can cause axial vibration to be equal or greater than the radial vibration amplitude. In case of overhang, axial vibration also very high compared to radial direction. And again, poor unbalance of overhang rotor, the axial phase F1 will approximately equal at bearing 2, means at the both this D and D in axial direction, the phase is almost same. So I think you understood clearly about the unbalance and what are the types of unbalance, that is static unbalance, couple unbalance and dynamic unbalance, how the phase varies in each condition. So we will study in the later sessions about the time waveform and further unbalanced conditions. Thank you.